Hello, in this video I'm going to explain the design of compressor. So first of all, head of compressor is determined using this equation number 1, which you can find in any thermodynamics book. So let me explain to you each and every term involved in this equation number 1. So Z is basically compressibility factor, R is universal gas constant, T1 is basically inlet temperature, Mw is molecular weight, K is ratio of Cp over Cv. This P2 over P1 is pressure ratio, that is pressurized across the compressor. So first of all, let's find the value of K. So K is determined using Cp over Cv, and since we can write Cv as a Cp minus R, so you can find, once you can find the Cp value, you can find the K value. So I have taken this Cp value from S1 HYSYS. You can use any other sources like empirical correlations. You can find it in literature. So after determining this Cp value, we can use this equation number 2 to get the value of K, which comes out to be 1.41. So now we need the volumetric flow rate. So using the mass flow rate that is given to us, we can find the volumetric flow rate at the inlet. So this is just interconversion of this. We know the molecular weight of process stream is 2.243 gram per mole, and we know the temperature pressure conditions. So using these values, we can determine the inlet volumetric flow rate. We can convert the units so that we can find the right type of compressor. So discharge pressure that is required as 1000 kilopascal, which means compression ratio will be 2 because the inlet pressure was 500 kilopascal. So using this volumetric flow rate, we can determine the type of compressor. So for that we need discharge pressure and inlet flow rate. So we know that inlet flow rate is 8.12, which is somewhat closer to this value, 10. We can take it as 10, and discharge pressure is 1000, which is this value. So from here we can determine the right type for our process is reciprocating compressor. Now we can substitute the values in equation number 1 to get the value of compressor head, which comes out to be 903.4 meter. Now we can find the temperature of outlet stream as a result of adiabatic process. For that we need inlet temperature, pressure ratio, and this K value. So substituting this value, this pressure comes out, this temperature for isenthalpic process comes out to be 109.9 degrees Celsius. So there is a limit that outlet temperature should not be greater than 204 degrees Celsius. So we know that our process is feasible. Now we can find the isenthalpic efficiency. For that we have this formula. So based on the outlet temperature, we can find the isenthalpic efficiency. We have taken the outlet temperature as 140 degrees Celsius. So when we substitute these values, we can determine the isenthalpic efficiency. After that we can find the power of compressor. So for that we have this P1, that is inlet pressure, V1 is inlet volumetric flow rate, this pressure ratio. So just we need to find substitute these values. So it comes out to be 1.044 kilowatt. So we know that isenthalpic efficiency is 69.3. so we can divide this actual power by this efficiency to get the actual power. That comes out to be 1.49 kilowatt. Okay, so that's all for the compressor design.